Braneworld Theory. The Braneworld concept was proposed by physicists such as Lisa Randall and Raman Sundram during the 1990s and 2000s. Their research sought to explain phenomena like the relative weakness of gravity on large scales by suggesting that gravity leaks into extra-spatial dimensions. The Braneworld hypothesis claims that our universe is just a thin brain embedded in a higher dimensional space where multiple brains may coexist and interact. Each brain, or universe, might follow its own set of physical laws, and we only experience the slice of reality that our particular brain occupies. Imagine a thick book where each page represents a separate universe. You're only able to read the content on one page, yet all the other pages exist concurrently alongside the one you're reading. The Braneworld idea opens up the possibility that the reality we see is merely a fragment of a much larger existence. Cyclic Universe. The Cyclic Universe hypothesis suggests that the universe doesn't have a fixed beginning or end. Instead, it undergoes endless cycles, from birth, Big Bang, and evolution, to a collapse, Big Crunch, followed by the rebirth of a new universe. The idea of a cyclic universe has roots in ancient cultures with the concept of the life cycle of the universe, and was later revived in modern theories. Physicists like Roger Penrose and Paul Steinhardt have studied models of a cyclic cosmos to explain phenomena that the traditional Big Bang model struggles with. Imagine having an hourglass. When the sand runs from the top to the bottom, you gently flip it over and let the sand flow again. Or picture the cycle of seasons where spring follows summer, then autumn and winter, evoking an endless loop. These images help us envision a universe that never truly ends, but continuously regenerates in a spiral of time. Parallel Universe. The idea of a parallel universe was first proposed by physicists like Hugh Everett III in the 1950s with the many worlds hypothesis, a concept originally based on the branching of quantum states. Although it was not widely accepted at first, research in quantum mechanics and cosmology gradually expanded this concept, laying the groundwork for debates on the diversity of the universe. Imagine standing at a crossroads. In one universe, you choose the left path, while in another, you take the right. In this way, every decision creates an independent universe where history, the laws of physics, and even natural phenomena could be completely different. With every step you take, you hear leaves falling, or the wind blowing in a unique way according to the path you choose. For instance, in one universe you might only be able to walk, but in another, you could fly or dash around like the Flash. This imagery not only helps us grasp the concept of a bifurcated universe, but also sparks our imagination about the endless possibilities of reality. Simulated Universe. The simulated universe hypothesis posits that all of existence, including us, planets, and galaxies, is merely the product of an incredibly advanced computer program. Imagine playing an ultra-detailed video game like Minecraft or The Sims, where everything is constructed from lines of code. According to this idea, our universe is nothing more than an elaborate simulation, crafted by a civilization so advanced that they can create a world indistinguishable from reality. This idea was popularized through essays and studies by philosopher Nick Bostrom, who argued that if a civilization could evolve to create realistic simulations, then the probability that we are living in a simulated world is quite high. He even pointed out that glitches in a game might serve as clues that our universe is exhibiting similar software bugs. Holographic Universe. The Holographic Universe hypothesis proposes a unique viewpoint. The three-dimensional world we experience might just be a projection from data stored on a two-dimensional surface. The holographic concept originally emerged from studies in string theory and quantum gravity. Pioneering physicists like Gerard 't Hooft and Leonard Susskind posited that information about all events in three-dimensional space could be fully encoded on a two-dimensional surface, leading to the idea that our universe is essentially a hologram. Imagine watching a movie in a theater. Even though the film gives the illusion of depth, it's all just light projected onto a flat screen. In a similar manner, the holographic universe suggests that everything around us, from houses and trees to planets, is merely an image projected from a hidden data source. Fractal Universe. The Fractal Universe hypothesis suggests that the structure of the universe is organized into repeating patterns, from the smallest scale of atomic particles to the vast scale of galaxies. According to this view, everything in the cosmos has a self-similar form, meaning the structure of a part of the universe can resemble the structure of the whole. The idea of fractal structures stems from mathematics and geometry, introduced by mathematicians like Benoit Mandelbrot. Later, physicists and astronomers applied fractal theory to study the cosmic arrangement of galaxies and the fabric of space, revealing a new perspective on the seemingly random yet ordered organization of the universe. The fractal universe helps us understand that there might be a fundamental order amid the complexity of the cosmos. It shows that regardless of the scale, there exists a specific form of organization. Many worlds interpretation. The many worlds interpretation is essentially an expanded version of the parallel universe concept. It argues that every time an event occurs or a decision is made, reality splits into countless branches, each existing as its own separate world. This idea was first introduced by Hugh Everett in the 1950s within the framework of quantum mechanics. Although initially controversial and not widely accepted, over time, with experiments and studies on quantum phenomena, this concept has been supported and become one of the prominent hypotheses in modern physics. Imagine standing before a multiple-choice quiz book where each answer reveals a new chapter with an entirely different storyline. Similarly, even the smallest choices you make generate a branch of reality. In one universe, you might become a hero, while in another, you could end up as a quirky goblin. Bubble universe. The idea of the bubble universe emerged from studies of cosmic inflation in the 1980s, later developed further by astronomers. While there isn't a single inventor of the concept, the work of Alan Guth and Andre Linde on inflation laid the foundation for these later ideas. The bubble universe hypothesis describes our reality as just one tiny bubble within a vast space filled with countless other bubbles. Each bubble could follow different physical laws and natural constants, creating a level of diversity that is almost beyond our imagination. This idea ties in with the inflation theory in cosmology, where after the Big Bang, space expanded beyond limits and formed independent regions, each essentially a separate universe. Illusory Universe. This concept finds its roots in studies from neuroscience and cognitive philosophy. Scientists like David Chalmers and various philosophers have questioned whether our sensations and perceptions accurately reflect the true nature of the world, or if they're simply illusions conjured by our brains. Imagine watching an animated film where every scene and character is drawn by an artist. Although the movie appears vivid and lifelike, it remains just a series of moving images on a screen. Similarly, the illusory universe suggests that everything we perceive is merely a display created by sensory signals, like a movie that our brain continuously projects for us. This perspective contends that what we experience, from sights and sounds to tastes and smells, is just the outcome of our brain's data processing. It doesn't deny the existence of the physical world, but suggests that humans only perceive a filtered version of true reality.